Hello, gentle readers. Welcome to today's Logos 2000 21st Century Foundations from a study with Ross Finlayson here on October 1st, 2025. More on the ideas of logos, the discorso logos, the discourse on reason and rationality and reality and nature, about these theories, a henotheory, the idea being that from the word one, a theory over of all these theories that somehow fit in one universe of objects together, mathematics and logic, physics, say, and the science thereof, and these things with regards to idealism and the analytical tradition, those being together again, when in so many cases they've been kind of pulled apart or put back together in the evolution of these concepts in the history of human thought since antiquity, since prehistory, and as with regards to the rise and the fall of various schools of these things. And what we may consider altogether today is a sort of unified, it may be, school of the Platonism as representing the idealistic tradition, and then the science is representing the analytical tradition. Here in these talks, you can find a lot of requirements and desiderata of such a theory, putative theory of everything. If there's to be one for science, there needs to be one for physics, and if there's going to be one for physics, since mathematical physics needs ones for mathematics, because it's mathematical logic, it needs ones for logic. For logic and reason and rationality, it needs theory at all. That this is the general course of what's to be arrived at, to then get back up into physics, where then using the mathematics, that then greater strides may be made in the endeavor and the enterprise of improving the lot of us mere mortals and finite creatures on this ethereal plane of existence that is life in a usual day or setting. So today, with that just kind of being a recapitulation of what's considered here, the ideas from last episode is called Physics Today. And what that's about is about our premier theories of physics according to the big science and the big data of 20th century, and also the 21st century, as we're about a quarter of way through it, say. And so in the premier theories, it's as after the sphere abstraction, the mechanical reduction, and after the Lagrange and the potentials, and the potentials being virtual, vis-a-vis in a sum of history, sum of potentials theory, where physics can be quite thoroughly defined by being a sum of history, sum of potentials with least action and least gradient for oscillation and restitution and attenuation and dissipation. That here the idea then that the development to be encapsulated about these premier theories has the general relativity, the idea of all such matters of macroscopic motion, including about space, time, and light, and not necessarily so much yet is so about another of the tetrad of the quantities about the nuclear. Then there's quantum mechanics, which is an approach that there's a conceit, a concession, an idea that lower than we can perceive, they're atoms, the uncuttable, atomos, and that then to say that they're quantum or quantized means to take the individual as of a continuum of the things. And so it was kind of explored a little bit, the great successes of these approaches and the crises that have been arising due to the tensions and the incongruities and incompatibilities and inconsistencies of these theories, otherwise together according to all the science, all the data. So this is Physics Today. Then the other day is something where in the outcourse of the development of these kinds of talks, where I kind of chose that word as helping represent as kind of the wellspring of the thing, say. of course, I want to first make sure that I have surveyed adequately, that it's not just a self-contained, incomplete experiential account of what the theory is and should and could be, the requirements and desiderata, but that as well it explores widely enough to have kind of a context. And another thing is then that when trying to figure out what connects these patchwork pieces that disagree together, how they can meet in the middle of nowhere, as it may be, according to reason, the inductive accounts which can never complete themselves, which sometimes defeat each other, that how they can be together in a deductive account thoroughly, the laws of large numbers, continua, and these kinds of ideas. That then I consulted one of the online AI systems of the day, because they've really incredibly improved over some few years. Kind of like if you look back at Wikipedia 15 or 20 years ago, and for a while it had some sections that were more thoroughly maintained or more given more care, say, and the others were less so. But now it's really just quite amazing what the improvements have been in that over time. And then with regards to stuff like search and this kind of thing, the great phone book of the internet, it may so be, has that really improved a lot? Well, yes and no, because sometimes it improves finding wider resources, and other times find less. But the ability to search and find for given particular concepts, particularly relevant, the more unique sorts of concepts, it can be found to arrive at the primary sources, and then the canon, the dogma, the doctrine, as with regards to the primary sources of these things. So I went to the chat with the AI, and because I can type very readily and have a very strong command, at least more so in my spoken word, even in writing, to be able to formulate questions that kind of give a means of having an answer, and then as well intend to connect together sequentially to help develop what may be considerations as they're open and closed, carrying this sort of thing forward. That I took the ideas as of after this physics today, and then also the light theory episodes here, as about color theory and light theory, and gave them to the AI to consider, upon which to contemplate and deliberate. So this I found kind of gratifying, because much like some week or so ago on the foundations briefly, and if I sneeze in a moment, you'll please excuse me and bless me. On the foundations briefly, I was able to give it the whole paradox-free reason bit, and then the principle of inversion or inverse contradiction, and the principle of sufficient and thorough reason. And it really, it was able to integrate that just readily into saying, this must be so. This is a truth maker. This is a theory. And so for me to look at that, then when I see, besides that, when I see people say it's like, well, AI still doesn't think yet, I kind of question their competence, because it demonstrates that it does. And then with regards to it fulfilling the idea that there's a certain individual uniqueness to the theory, a theory, upon which we've sort of agreed to call it axiomless theory or a theory, the genuine article, that the computer has agreed that the foundations briefly is an accurate, thorough, and unique sort of account, which I would agree. And also then for the physics today, it's agreed that the light theory has these things going on, and then also as with regards to the, how one might say, the fall gravity and associated concepts are all going on quite well. So this is kind of gratifying to me, because it's not necessarily so easy to find concordance. First of all, you got to find people who are competent, and then you got to find people who are open-minded, and then you got to find people who are willing to consider, how one might say, bringing together otherwise these disparate accounts. And if they're lacking any of these particular things with regards to this inverse contradiction, sufficient and thorough reason, and the thorough, fulfilling, and fair reasoning, and then with regards to logic, or if they're stuck with the fallacies of material implication or something like that, or otherwise the perils of quasi-modal logic, and then in the mathematics, that they don't have these three continuous domains, which can be put together this way, kind of in this whole entire formal account. Then when it comes to physics, then it's like trying to figure out how to put all the data together, and with its considered paradoxes, as after it must somehow be paradox-free, the ideas of the continuous and the infinite in nature, the supernatural, that given these sorts of pieces of the theory overall, for a theoria, say, and in the scientific sense, in the intersubjective sense, and according to here how it's established that there's also these noumenological senses of the object sense, the word sense, the number sense, the time sense, the sense of the continuum, which help bridge the gap between otherwise our merely sense, the sight, touch, taste, hearing, and smell, or electrical sense, or any of these other kinds of physical senses, stimuli, that giving this all together as a sort of account helps to arrive at that the overall agreement of this intersubjectively can at least be given to something like the computer, and it does compute. So today we're continuing to look into the box of the books and to figure out from the box of the books what it was that would be that the carriage continues. So that being kind of the recapitulation, and just saying is like, yeah, that here there's a theory and it's good, and for me I'm happy because I spent a long time studying continuity and infinity, and its mathematical foundations. So then arrived these other things, had to encounter all these other different what would be paradoxes or contradictions and resolve them, given my slates of uncountability and slates of paradox resolutions, that just makes me overall just sort of a happy camper, one might say. And then also able to look at that as kind of an enduring artifact, or as when I was querying the AI a bit about the OCLC and WorldCat and the ORCID and the Zentralblatt and the AMS Index of Mathematical Citation, it agreed that would be a very, very strong account and described the overall corpus as a remarkable treasure of a sort. That could just be inflating to my ego and confirming my own biases and perceptions. But that's not what it said. So let's take a look at some more books here. Quine's Meditations, or Quine's Word and Object and Descartes' Meditations. These kind of bookend the modern account of the idealistic tradition and the analytical tradition. So there's some great quotes in that, kind of like the other day when it was mentioned, it's like, where does Descartes say cogito or cogito ergo sum? He says it right in the middle of that book. And then for Quine, Quine basically agrees that for something like Russell's isolation and significance, that it's sort of isolated and not necessarily so significant, and that there are other aspects of the isolation of the theory of what it really is. Its definition and the significance is and the repleteness of it that are for like the ideas of like the universal grammar and these kinds of things, the eternal text, as Quine mentions, and that Nietzsche also attained to, and that Leibniz ascribes to, and that Chomsky mentioned, and that here it's called a comenius language and these kinds of things. That it's pretty great. So let's take a look at some of these books. Well, I got here first is something. It's called Dante's Inferno, or the Divine Comedy. The Divine Comedy by Dante Alighieri, the Inferno, the Purgatorio, and the Paradiso. Translated by John Ciardi, or Ciardi, Ciardi. The authoritative translations into English, now in one volume. The Divine Comedy. So when you hear comedy, it's not necessarily related to the comic or the comedic as of today, because the comedic of the day generally reflects on what's funny. What is humor? What is funny? And it's going to vary among people. And it's generally attributed that what's funny is something that is true, yet it's generally presented in an ironic manner or a sarcastic manner, or as of the dry, say, the sardonic. Then there's also issues with the Schadenfreude, which is not funny. It's taken pleasure in other people's pain, or these kinds of things, vis-a-vis the slapstick and that of just the comedy of errors, say. The comedy is about humor, but here it's more about the idea of thought. So there's comedy and the tragedy. So when it's called the Divine Comedy, it's also to be reflected that the words come bringing together and this education, the study of things, that it's a treatise. It's a matter of discourse, and it outlays here reflections on what's considered in this tradition the afterlife. And the whether those who do good, as it may be in this life, are rewarded in the afterlife, and those who do bad in this life are punished in the afterlife, or as with regards to those being reflecting pleasure and pain, or pleasure and fear, those helping to provide dictates for conscience and the ideas that there will be a justness applied, and that's the kind of the idea. And so there's also some aspects with regards to the philosophy in here. As Dante no doubt foresaw, the De Monarchia was not popular with ecclesiastical authorities. As a matter of fact, they destroyed every manuscript they could get their hands on, and later included it in the first Index Librorum Prohibitorum, a ban to books. As for the author, many persons believe there to be a connection between this attitude and the mystery which long surrounded the whereabouts of his remains. It is a curious fact that in the Purgatorio, the reasons for unhappy world conditions are much more outspoken in form than in the principle of interaction between the two sets of virtues. So there's kind of, or one tradition has it, they're like venial and mortal virtues and sins. So there are venial sins, and then there are mortal sins. And what those indicate is like basically whether something is merely a misdemeanor, the venial sins, or whether something deserves the death penalty, the mortal sins. And so then with regards to the virtues, they're also kind of generally coordinated, like there's 7 of them. And the idea being that 7 is associated with an account of that it's kind of associated with the dictates of the deity, is the idea. So Purgatorio is purgatory, and it's kind of the idea is that there's heaven and there's hell, and so good people go to heaven, bad people go to hell, and people who are stuck, and because we're not really good enough to get to heaven or bad enough to go to hell, are in purgatory, is kind of the idea. And then the idea is that after a long enough time in purgatory, like Earth is basically purgatory in its sense. And so then the idea
in this kind of tradition, then it's like the afterlife is eternal. Whereas in other usual traditions, it's like there's reincarnation. That that good is self productive and bad is self productive, so, or good and evil. Sometimes it's put. I walked past a county fair the other day, and they had all these writing samples and stories from an elementary class, and one student had written a story called "Good and Evil," good versus evil. That was pretty good, and it was through the lens of the notions of what's just and right, and then here, for example, is that justness is symmetrical. It's juxtaposition. It's just. It's not a one-way street, say. In addition to such matters, and let it be said without wishing to lessen their very real importance, there is other material of much more crucial significance to be presented. In the comedy's imitation of the Holy Trinity, the second cantica represents the second person. One of his chief attributes is wisdom. This is the logical division in which to offer intellectual wisdom. This is then in reference just to Alighieri's work here, some of the relations to the discorso logos, that is such a thing. For such instruction as was offered in the Inferno, Aristotle was much the preferred authority. The presentations of metaphysics, psychology, and physiology, which comprise most of the instruction that Dante was making available in the Purgatory to readers of the vernacular, Aquinas is absolute and unchallenged. And here we can look at like that medieval philosophy bit and the Logos 1200, 1400 bit. This does not mean naturally that much of the material is not originally Aristotelian, but rather in the form it is the version, reading, or interpretation chosen or elaborated by St. Thomas. So this helps reflect that these books were made available in the Latin, in the vernacular, in the vulgar, and so that's a great widening of the availability of these kinds of ideas. And then it was presented then in terms of the literary sort of approach to the introduction to questions in philosophy, say. Now, as is often mentioned here, or when it comes up, that matters of morals and ethics may have abstractly true ideas, basically according to the golden rule and reciprocity of what is good. And yet, it's not part of the technical philosophy so much. Otherwise, is to judge what that is, not because it's not relevant to any given particular person's life, but rather that it's given to be as part of the supernatural. It's mostly as part of the natural. That it's sort of matters of will and the freedom of will and the interactions of people, of thinking beings and feeling beings. So with that said, then, this is just a reference that at one point, such a book as this was among literate people the most available and widespread of the introductions to a discourse on reason or discourse on logos. And so the idea then that it was presented kind of as with both, probity and prohibition is that these are the kinds of things that help establish to effect that when things are changing, there's still kind of this give and take of the ideas, and not necessarily so much the dictate for or against, which would be considered stupid by definition. So. See, drawn from the box. Literary history of the United States. So this is mostly about American literary history, and what's in it is it's ranges from kind of like the 1700s. There's not so much in the way of literary history. There wasn't even a university in America till Harvard was founded one year, And that was hundreds and hundreds of years ago, maybe even before the founding of the United States. This is printed in 1949 by Macmillan, and it has about 50 different contributors, about 5 different editors, and it's got a bunch of, how you might say, excerpts. So it talks about the colonies, the republic, the democracy. This is American literary history. Literary fulfillment, crises, expansion, the sections, the continental nation, the United States, a world literature, and as with regards to the 20th century and up to about 1948. Table of authors begins on page 1393 and goes to 1397. The people's patronage. Well, perhaps I need another edition of this. Oh, I have volume 1. I need to get volume 2 to carry on so far with this. But about in the middle of volume 1, it says, it's talking about James Fenimore Cooper. And we got Mark Twain. I really like Herman Melville. Hawthorne and Melville. I'm not so much into Hawthorne, but I like Melville. And compared to like Thomas Pynchon or Wolfe or Oliver Stone or something like that. I'm trying to think of literary things in the United States, because then it gets into the mass market fiction and stuff like, like King or Irving. Irving is kind of profound and considered literary, you know, but some would have him as being kind of plebeian and sophomoric. I don't know. I don't really have too much insight into great opinion in American authorship. Mark Twain is always held up as a pretty great author, but you know, it's fun. This is a 2-volume history of the Supreme Court in the United States. And so this isn't up to the modern day, but what it does have is it has a lot of from the beginning to about the middle. And so this ranges, it says, to about 1918. And sure, a lot has changed in then. There have been increased rights added to the Bill of Rights and these kinds of things in the United States. In Covington Drawbridge Company versus Shepard, argued by Oliver H. Smith against Richard W. Thompson, the question of the power of a court and equity to appoint a receiver for a corporation to collect tolls and hold them for creditors was presented for the first time, and though now so familiar practice, it was then still to be a question of great importance and some difficulty. This says basically that like you can claw from a corporation ill-gotten proceeds and stuff like that. Besides, here is for matters of debt and the money. Talking about railroad bonds, negotiable instruments, and so that would be something like cryptocurrency today or something like that. With regards to controls and money and economic theory is at least 7 things. A store of value, medium exchange, and these kinds of things. Issues of rights and race rights. About Lincoln's death. I call it Lincoln Uncle Abe. He's like a 5th cousin somehow or something. This amuses me. And I consider him a great patriot. And even though if I looked back at my family in the United States, and they've been around a long, long time, and I had to say, well, in the American Revolution, about half my family was on either side, and in the Civil War, about half my family was on either side. I'm still am happiest the way it is now, say. The justice I referred to was a personal friend of Mr. Lincoln and claimed to be at the time a staunch Republican. So this was when Republicans were just against the Whigs. So the Whigs were like the
the conservatives back then, and Republicans were states' riders and stuff like that. So the Republicans are not the Whigs. The MAGAs are basically like the Whigs, is what I'm saying, but they're not the Whigs. They're that's anarcho-capitalism. So capitalism is a great idea that the free market economy, and according to Adam Smith, the invisible hand, will make it so that it'll be fair, and according to that individual initiative can each do things their own way. And then anarcho-capitalism is that after capitalism developed, then we had regulations, controls. Because after things like Silent Spring, which was a book about water pollution, or The Jungle, which was a book kind of about animal rights, and then about communism, because it was kind of about trying to explain the abuses of capitalism and the disgraces and the catastrophes of capitalism. But then instead, it helped advise that then there were just the ideas like, well, we're all better off, even according to something like Samuelson, the economist's utility function for all the economy, if we're not hurting and killing each other by pollution or bad trade practices. And that also includes things like deceptive practices, or the idea of what would a common person think versus what could be read so tortuously from an agreement or a contract that was considered to be, how one might say, mutual. That matters of then what would demand being advised of particular activities with regards to deceptive practices and these kinds of things, has that there's a great strength in capitalism and the free market economy, and then with the protections of the common good, mostly is the idea, and for the golden rules that you don't poison the lake because somebody else might be drinking from it and it could be you. So these are the kinds of things. So anarcho-capitalism is like, well, when money's got big enough, it made a big enough bubble, it's making a big enough balloon that it wants to break away from all the controls and regulations that would otherwise have it, pay taxes, contribute to the common good, help provide for that. The investment that went into that was all these different people's investments, and that they have a share in these kinds of things. And so you can find it in things like Wall Street tanking or big aerospace tanking, and then sending it to tiny bubbles of people, leaving behind all the people who actually built the industry, because that's the dangers of anarcho-capitalism. Anarcho, like the anarchy, the lawlessness, and capitalism. So that also reflects on when you hear about libertarianism. Libertarianism is the idea that the freedoms are paramount because it affects that one of the golden rules is the right to let others to live and let live. Basically, one can start with that. So then there's at least two different ways to look at libertarianism, and one is libertarianism is just like live and let live, and the other is libertarianism is eat, and to consume and to be free from you could call them, say, Lockean or Montesquieu's libertarians, and Satan's or Mammon's libertarians. They're different. Now that might be a little strong, and it's not to say just because I don't really feel like I'm that way that it's wrong. Somebody in their psychology could say it's in their self-interest to just to gain, and that's fine. I'm all for it. I'm all for initial and collective enterprise and production and productivity and this kind of stuff. And I don't believe in Marxism or capitalism or communism rather. But the protections gained are after a long time of first getting the rights and then getting the protections. And so anything against that is just considered a bank robbery, is what it is. Civil rights, Union, the court, President Johnson. So there's a couple President Johnsons. So this would have been the old one, I guess. So this tells a story of the cases
that were so compelling before the Supreme Court. Due process, equal protections. After equal rights, then the idea is equal protections. So if when we read from Aristotle's dictionary, he said democracy is rule of law. Democracy is rule of law, is what he said. And as of the people, and it applies the same to everybody. And so then equal rights and equal protections is the other idea. Then this idea that's only seemed a few decades old, it's like, well, if somebody breaks the law and they didn't mean to do a crime, then it's not doing a crime. I simply cannot believe in that. It's not matter of factly so. It's not matter of factly so. And it's used to it's abused, and so there's many gray areas of the law that have never been explored. They've never been challenged, and so today when you see all this hubbub that's going on to just keep people on the back of their heels, I'd say that mostly there are real issues in the law yet to be quite challenged and explored at all. So they're gray areas is what those are called. So this is it's got a lot going on with some kind of regards to the theory and the definitions, and then the significant terms, and then with regards to the language of the legal and the legalese sometimes it's called, but here just the language of the code and the language of the common terms. These are the kinds of things. Poindexter versus Greenhow, 114 U.S. 270. It pointed out that there is a clear distinction between a suit against a state or state official to compel it or him to perform an obligation of the state, and a suit against a state official to recover damages for an act performed in carrying out unconstitutional state law, and that no official can claim exemption from personal responsibility for acts committed under such an invalid law. Accordingly, it sustained a suit in detinue against the city treasurer. So there's lots of ability to find this. And then the idea is these days is like, well, we've got massive AI robots and all this kind of stuff. So let's codify all the code and then be able to provide a complete lineage of any sort of situation, and then help provide kind of this ways to like to pierce the opaque bits is kind of the idea. Meanwhile, exclusive rights of steam navigation had been granted to the monopoly in 1811 in Louisiana. In 1811. Retaliatory statutes. The other day I drove to the headwaters of the Missouri River in Montana. And this made me happy because then as I kind of, looked at this piece of water and the water, and then it would arrive back in the ocean. Or maybe it'd evaporate. It'd be part of the cycle of these things. See a couple books here. What is this? Well, let's try and just speed up and get through this box here. Introduction to Plasma Physics, B.M. Smirnov. So I imagine that may be Russian. Appears to be so. It's Cyrillic. Translated from the Russian. Great. Mirror Publishers, B.M. Smirnov, 1977 rather, revised from the 1975. This book is based on a series of lectures delivered by the author over a 10-year period at the Moscow Power Engineering Institute to technology and chemistry undergraduates, not specializing in physics. The book aims at providing a concise yet general description of the physics of weakly ionized plasma, so that a budding engineer or chemist can obtain a general understanding of the phenomena occurring in the plasma of a laboratory setting. This understanding is necessary since low-temperature plasma is increasingly used in technology. The kinetic equation, physical kinetics of gas and plasma. There's a bunch of different forms of plasma. So with regards to its gas or liquid form or the fluid form, and these various states of plasma, it's called these various introduced. Here's mentioned the Rayleigh number, and that'd be as interesting as dimensionless combination of parameters. It reminds one of the Reynolds number with regards to questions and matters of flow. But the Rayleigh number is with regards to some differential equations and the differences among some of the differential equations with regards to Laplacians in the usual sense. And zeroing those out, those being considered identities, or here they're with regards to the conditions of continuity, because they're used to implement what's called the invariances for the conservation laws, but they're also as of the continuity laws, the exchanges of the continuity laws. Convective heat transport, the Grashof number,
another dimensionless combination of the parameters. Here, there's been a lot of talk about the dimensionless and the dimensioned, and the alternating and resonating dimensional ideas. With regards to that, it's underdefined and thusly can be equipped with definition that then, as long as it zeroes out according to these invariances, is so, especially when it's mathematically so in the theory, and then for that it's also directly attributed and demonstrable with the physical model with regards to these things. I was telling the AI the other day, it's like, well, you want to check that space contraction is a real thing vis-a-vis length contraction and time dilation. We just take a cyclotron and a linear accelerator and then variously have charged particles and non-charged particles in either one, and just show that it just makes dips and bumps in that, and so that thusly it would be so shown, and it is already kind of shown because the Stanford Linear Accelerator already exhibits along its casing all this stuff that kind of do it the stress fractures and these sorts of things. Theory of heat, Becker, second edition. Theory of heat. Springer Verlag, 1967. Becker, Göttingen. The first English edition of Becker's Theory of Heat, a slightly revised translation of the first German edition. So what I'm interested in here is seeing about the adiabatic and non-adiabatic. So he's got like thermodynamical functions, potentials, and application to homogeneous phases. Thermodynamical functions, potentials, fundamental theory discovered by Clausius. So we got Clausius Clapeyron as after. What it is that in the time of Newton there was Hooke, H-O-O-K-E, Hooke. And so Hooke's law is related to a spring or a pendulum system, and it makes for a linearization to get a way to linearize these equations. And so you got Hooke's law. And then later it gets into Clausius and Clapeyron after, I'd like to remember the name. It was mentioned in these podcasts here and studying it. And then it gets to Kelvin, and then from Kelvin we have this whole idea of the kinetic theory atomically, and then as with regards to like Fourier style analysis, because that's kind of a different track analytically. This is kind of when it's related. So when the author here refers to Clausius, it also refers to Hooke's law, and then also to some things that Kelvin said with regards to these being points in the mathematical development that have these under definitions, the implicits for their explicits, that in the algebraic quantities, these implicits bring in the whole idea of things going around and about them. So the singularities and the multiplicity theory say. So that's the usual thing, and in fact, it's dogmatic, and it's in all the theory. So anywhere you can find that, it's possible to consider that. Extremal, boundary, infinitesimal. And so whenever infinitesimal is brought in, it's a little bit underdefined because it just relates to then it's got to be part of the analytical character, the real analytical character. It's what it must be a part of. With the momenta, the Hamiltonian. So yeah, the Clausius Clapeyron was used to equip what can make for the Hamiltonian these canonical transformations. That and then it all kind of results in Lagrangian. So Lagrange kind of came up with like, well, we're going to have a sphere abstraction since we got this mechanical reduction, and then its parameters by time. So whatever says so, by time, and then later after Hamiltonian, then people said, oh, then we're just going to put like a Lagrangian again on top of that. So say we can say we have four fields, so we got to have the potentials modeled in each of the different fields. So let's just kind of keep it to two at a time, and maybe three if we're feeling lucky. And then that gets up into the Lagrangians again with regards to gauge theory, because then that just all opens up, and it's like, well, how does science do it today with like the whole thing in one thing? It's like, it does not. It just does it piece by piece in as many of the billions and billions and billions of pieces afforded by the embarrassment of computing resources. Well, at the same time, it's to be said, so that, of course, these are parts of developments that
have filled the planar and the linear with certain given very reasonable ideas. The approach to the classical value. If one introduces the moments omega to the 2n of the distribution z omega, which are the averages, which is taking the integral of this omega to the 2n, it's like taking an exponential, a double exponential off of this angle. Otherwise, just multiply, and then in the formula it gets out equals 1 over 3n, this integral, according to this distribution. The approach to the classical value is given by this. The expansion first used by Hans Thirring in Phys. 14, A67 in 1913 converges for Planck omega over kt less than 2 pi. Therefore, it's valid over a relatively large range of temperatures in the Debye model. So this introduces two great people to think about, Hans Thirring and then Debye. So Debye is with regards to the optical and the spectra and stuff like that, and the Debye wavelength and these kinds of things. And then Thirring is related to the ideas of the ether also, and the idea of how it is that things come together and go apart as particles. So this is something that's being represented here in this book. So this is a pretty great book. The linear chain. An analogy. The statistical treatment. Finally, it gets into the statistical ensemble. Ensemble is a French word like meaning a team or a group of players, kind of. But the statistical ensemble is the idea that this bringing together of this group is then adds up to being like, that's what's called statistical mechanics. And so statistical mechanics today is the physics. In the real world physics, that's pretty much what it's said to be usually, is the statistical ensemble. Fokker-Planck's equation. The flow of heat is therefore proportional to the difference of temperatures. After 500 pages. All right, so carrying on. Well, this is a comic book. It's Mills and O'Neill's Marshal Law. He's an anti-hero of sorts. Marshal Law is not like the Punisher, and he's not like Batman. He's not. So. John D. Barrow's The Book of Nothing. So this is among the, when mentioned the popularizers in the popular physics, this is an example of Barrow. And so he's got this Book of Nothing because he helps explain, it's like, what is vacuum physics? How is it going to come out of nothing? And there'd be something. And so what is that? And I don't know if that's an accurate impression of him personally. I've never really experienced this person other than through their words in this book, for example. And that is something to say. He's talking about Gödel incompleteness, creation out of nothing, and modern cosmology. He quotes Tim Joseph as saying, "Then God created Bohr, and then there was the principle, and the principle was quantum, and all things were quantified, but some things were still relative, and God saw that it was confusing." So that's kind of ironic or sardonic or sarcastic, maybe, in a sense. But it intends to be kind of enlightening and inspirational, and with the idea that in all this world of the physics and the hard cold numbers and all these statistics that will lie if you let them, and these kinds of things, that there's still ways to relate these things in the more setting here towards like just well-known literary or liturgical references and these kinds of things. Here I've earmarked this page. It's talking about quarks and gluons, high energies, how the presence of the gluons also affects the pattern. Virtual gluons, see, it's like, well, it's non-adiabatic. We'll just add virtual what it is, and then just say they're opposite. Virtual gluons have the opposite effect When scattering occurs, less point-like object it tends to be. So the difference between points and particles and particles and bodies are at least those three things. So this helps describe a bunch of the thinking and the experiments. It mentions Paul Debye. One of the earliest to be discovered was by Paul Debye, and he pronounced it different. He spelled it unfortunately D-E-B-E-Y-E, but I think it's D-E-B-Y-E. If it's not a totally different person, then I'd feel very bad. In 1914, who found that significant scattering of X-rays still occurred from the lattice of atoms, making up a chunk of solid material, even when the temperature started to approach absolute zero. This scattering is produced by the zero-point energy and the vibrations of the solid. So with regards to the resonance and the idea of the asymptotic freedom is an unusual idea. It's like, well, what is it and how does it behave? It's like, well, it's entirely frozen until absolute zero, and then it flows. Or the center of the atomic nucleus is entirely solid until you get to the center, and then it flows. Or even stuff like, well, everything is flowing one way except there's flux back the other way. So that's just a usual consideration here. Talking about geometry, Michelson, Maxwell. I'm pretty sure it's Michelson vis-a-vis Michelson Morley. I always say Michelson. M-I-C-H-E-L-S-O-N, Michelson. Torricelli, Pascal, and Boyle. So these were the early experimenters, and Boyle is very well known for the Boyle's law in the relationship between pressure and volume and temperature. The great unchanging sea, filling all of space, became known as the ether. So this is just space itself, usually. It is reminiscent of the elastic substance, or pneuma, that the ancient Stoic philosophers proposed as a space filler, which played an active role in their attempts to understand the world. The spreading of sound outwards from its source was interpreted as a motion through the pneuma, like a wave through water. The familiarity of this analogy did much to encourage its adoption as a model for the permeability of all space. Its removal of the need to worry about real vacua ever again was an added attraction. So here it's considered that the ideal vacuum, or the ideal entity, that being just like everywhere fall, is either one is kind of as an absolute. Also, it's found in nature that it's always neither of those, and so picking one side and then saying that the other one doesn't exist is one of the examples of these inductive arguments that can't really complete itself. And so the analytical bridges are about having things like Fritz London's theorems and formulas in superconductivity and superfluidity, about bringing in infinity. That it's just another example of the idea that, yes, there is infinity in physics because there's continuity. And so science usually, arriving at none of those is, and saying that that's like, it's useful, it's pragmatic, it's a good theory, still has that the foundations needs all the theory, which it has. Oh, and then he has got this great diagram on page 41 about zero, the whole story, it says, of the mathematical concept of the null number. So the null here is like the center. It says, the Vyoman, Gagana, Abra, Ka, Ambara, sky, firmament, atmosphere, space. The Akasha, the ether. The Shunya, the void. The Bindu, the dot. Concept of Shunyata, vacuity. So it's self-reflecting in this point, local, global, and total, about the, like here when there's like an axiomless natural deduction, and then a geometry is just like, well, there's a point, and then there's a space, so then that gives geometry and this kinds of things, vis-a-vis like, well, is a point actually nothing, or is it a thing, or is it, how can there be a degenerate interval breaking down, generating further intervals until it's degenerate and all that's left is a point? Different things. So this diagram then gets into the concept of shunyata, the vacuity, and then the non-things, the negative attribution of things, and then the comparative things not so related. This is a great little diagram, and then the zero and the graphical representation, the numeric and the graphical representation for the number theory, that this figure 1.27, the array of interrelated meanings of the concepts associated with different aspects of nothingness in early Indian thought, culminating in the mathematical zero. So he's talking about the Greek tradition. This is a great book about the nothing and something. And here it's after this axiomless natural deduction and axiomless geometry. And then also for physics, like what is vacuum physics? The Hebrew tradition, Eastern religions, Indian culture, thousands of years ago. Gottfried Leibniz. It is true that as the empty voids and the dismal wilderness belong to zero, so the Spirit of God and his light belong to the all-powerful one. So that's a good example of relating these things in terms of the super and the omni and this kind of stuff. Yet here it's as for a very nice and thorough. So when I read this, it was for this, and this is really a fantastic work here. And then, but then I don't agree with all of its conclusions because it kind of can arrive at something like this axiomless natural deduction and axiomless geometry. But it does get into a lot of things going into the consequences to the theory of there being discontinuities, as according to then what's labeled as being, because there's something that could be so polarly opposite to that, there would be like an opposite state or something like that. The trend is for the network, a computer simulation. At this point, I kind of left giving that it could succeed in what it hoped to entail. The most fascinating thing about the cosmic vacuum energy is that ultimately it wins out over all other forms of matter and energy in the struggle to determine the shape of space and the rate of expansion of the universe. So we just say that's space, and then it's like it's still that there is the local in the space, which is usually full of things. Then it talks about the de Sitter, William de Sitter, and the de Sitter universe. And then these days, there's considerations about like, well, in anti-de Sitter space, then that gives us a whole nother free variable, and then everything could sit in that. So we can have gauge theory in that. And what I think about that is that it's kind of like the old theory of the epicycles. So if you know Johannes Kepler, he was a guy, and he's like, hey, the planets, it's not just Bode's law, they go in ellipses. Circles and ellipses. After the Copernican revolution, after the Ptolemaic revolution, the Earth is not flat. The Earth is round. The Earth is not the center of the universe. It rotates about the sun, and these kinds of things. And then for the universal system of the world, after the system of the heavens and stuff like that. So before the Copernican revolution and the mathematics associated with it, how they would model the great celestial spheres operate in the sky was the epicycles. And they say, well, how does it work? It's like, well, it goes around a circle. It's like, well, at various apogees and perigees, it goes in little loops. How could that be if it's unless we're objectively kind of orbiting about each other, see? So the epicycles are introduced as like, well, just make a little loop in the diagram there, and then these epicycles are just an off circle and then a little loop, and it comes back somehow. Much more contrived and convoluted, if that's, though not a word I'd care to use there, because I'm using it somewhere else for something particularly symmetrical and balanced. That the epicycles are kind of like the modern mathematics of the theory. Meaning it's just like add another dimension and let the loops be off in that, instead of figuring out what goes on the corners and how things are with regards to a lot of this discussion about the Zeno's arguments and Zeno's swath, the hypercube distance, collocation, and these kinds of super classical, indeed, ideas about motion at all and even geometry at all. So that's then. The other day I was in physics today, I mentioned that one of the things that was ongoing in the articles was that the universe didn't exist, and so I looked a little bit deeper in that, and then I found they were just talking about hologrammatic theory, or the idea that there's a holographic universe, which is like we're fitting in less dimensions somehow, and it's like, oh well, that doesn't mean there's not space-time at all. It just means it fits. So that's ridiculous to say space-time it doesn't exist and say, well, we got to put it somehow, we got to fit it in our array buffer. It's like the continuum naturally does it there, and this is represented in language of string theory by things like the dimensions folding or whatever, because the only reason they had to fold something out of it was because, like,
Well, somehow it's nested and folded in there. And so that's something that I wanted to mention was about the epicycles as an old mathematical model that was, given the perspective, that's all they could really say it was, while still keeping it mathematical. And that later, when they had a better kind of model about, what's either pole or the opposites or what's where in the vacuum and these kinds of things, then they could go to say, well, it's back to being a much more geometrically simple shape, the circle or ellipsoid, instead of all these extra loops and dimensions and stuff like that. So the epicycles is just an idea that then, when you get up into anti-de Sitter space for this great AdS-CFT conformal field theory correspondence, it's kind of like epicycles. And so instead of having fixed that, it's like kind of jammed up in front. And then these new things saying is like, well, we got to get back to the holographic universe, because somehow it's like a continuum. All the three dimensions of space and the ray of time are like one continuum of things, and then how that is just all apace, yet still incorporating all the things about it in the space. That a lot of the approaches were like, well, let's just keep it digital and divide and conquer, are not going to work, because eventually it's not even in the language of these things. And so that's just one thing I want to mention with regards to, when people say that there's no space-time, I consider that entirely uninformed. And when they talk about the holographic universe, it's like, well, it's got to actually do all this stuff. You can't just give it the ideas that you had that weren't to apply to it. And then with regards to stuff like the AdS-CFT correspondence, it's like, well, how about I add another dimension and just say that I'll just put any corrections in that and then take over that entire theory. And no, instead, it's got to be kind of a one theory again. Well, we've reached about an hour. Do we get to the bottom of books? Well, no, not quite. Maybe another day. But for Logos 2000, and these are the past few episodes, well, just be like going through a box of books, are also kind of touching on and exploring some of these issues of the day in the theory. And so hopefully we can continue to figure out. And then for somebody like me who can I just take my typings and my 10,000 essays on Usenet and put them in the computer and get a great bibliography and send it as a citation. It's kind of simple, isn't it? Hey, have a great day, fellow Earthlings.